My goal with this video is to hopefully start bringing the quantum idea together, and it'll hopefully start making a little more sense to you. And the other thing is you'll start to see some of the practical uses of the quantum numbers that we talked about. Now, first thing, quick review. Remember, orbitals are the calculated shape of where the electron is most likely to be. So this would be considered an orbital. This is the shape where the electron is most likely to be found. Now, each orbital holds 2 electrons, and here's an example, like the p sublevel has 3 orbitals. The s sublevel, so this is s, p, d, and f. The s sublevel only has 1 orbital. This is just showing you the 1 orbital in the first energy level, second, third. So this is another single s, another single s. Notice they get bigger as you go up to higher energy levels. Now the d sublevel has 5 orbitals. The f sublevel has 7 orbitals. So we got 1, 3, 5, and 7. And here you can see we list the single s orbital as a box. Now what this box is really representing is that sphere shape that the orbitals are found in. Same thing here. We've got our x, y, and our z orbitals. So the p sublevel has 3 orbitals in it. And remember, they're shaped like this. The y and the z, I guess you could put, orbitals. So these boxes are representing those shapes. And I wouldn't even try to draw the 5d sublevel orbitals. But what I want you to know, we did the shortcuts last time. We've got our sublevels here. So our quantum, or our energy levels, are our n values. Then within the energy levels, there are sublevels. Those are our L values. So the sublevels are S, P, D, and F. Now there's 1 orbital in the S sublevel, 3 in the D, or P, 5 in the D sublevel, 7 in the F sublevel. So it goes 1, 3, 5, 7. It goes up by odd numbers. Now the number of electrons, remember each orbital holds 2 electrons. So if we've got 1 orbital, it holds 2 electrons. If we've got 3 orbitals, it's going to hold 6. 5 orbitals will hold 10 electrons, and 7 orbitals will hold 14 electrons, because each orbital holds 2. So I literally just multiplied by 2 for each of these, all the way across. Now the possible m values. Remember, S sublevel is spherical in shape, so no matter how you orient it, it's always the same orientation, however you spin it. So we just give it a value of 0. A p sublevel can be oriented on the x, y, or z axis, so we give them m values of x, y, or z. Now the d sublevel, we just number them 1 through 5, and the f sublevel, we number them 1 through 7. Now there's rules that electrons have to follow. The first one that we'll go over is Hund's rule. That says that in orbitals of equal energy within the same sublevel, all orbitals must contain 1 electron before doubling up. So everyone wants their own bedroom. So before I move on, let's look at like a p sublevel. So in that box sheet, a p sublevel looks like this. We got the x, the y, and the z shaped dumbbells that will represent with boxes. If I put an electron in, I draw it as an up arrow. If I put another electron, let's say I have to put another electron into this sublevel, the next electron would go here. It would not go in this box because they like to single up before they double up. The third electron will go here. Now the 4th electron would go in as a downspin, and we'll talk more about that later. But I wouldn't go like this. I would never fill it up like this. They would never double up while there's still empty orbitals that are of equal energy. The electrons like to spread out. And again, Mr. Crone's upside down dorm room, that's his example there. The Aufbau principle says that electrons will occupy the lowest energy level possible, or the lowest energy sublevel possible. So they fill from the bottom up. And then Pauli exclusion's principle says that no 2 electrons will have the same set of 4 quantum numbers. So that means every electron is different. They can't have the same address because they can't be located in the same spot. Remember the quantum numbers, the 4 quantum numbers give the electron its address, and no 2 electrons can occupy the same space. That's not possible. So they must have 4 different quantum numbers because they're in 4 different, or they're in different locations. I'm going to skip this and come back to it. So the quantum number for electrons. So you have this table in your notes. If we have our first electron, the very first electron that goes into an atom, we're going to go back to here now. I'm going to look at this. The first electron, where would I put it on here? Now we got to follow the 3 rules. The first rule says that, Aufbau's rule says that the electrons fill the lowest energy level first. So I go down here, this is my lowest energy level. So I'm going to draw my electron as like we call these an up spin, and this is a down spin electron. So that's typically how you draw them. So the first electron goes in as an up spin in the 1s because this is the lowest energy orbital available. Now, if I go back, that electron went in the first energy level. It was in an s sublevel. And s sublevels always have a quantum or a magnetic number of 0. And it was a plus 1/2 spin. It was an up spin. Okay, now let's keep that first electron in there and let's put a second electron with it. The second electron, because this orbital can hold 2 electrons, it goes in as a down spin into that same orbital. Because there's no lower orbital to go in. There's room in that orbital and it's the lowest energy spot available. So let's go back. It's still in the first energy level. It's still in an s sublevel. So we still got all this is the same. So all these are the same, but Pauli exclusion's principle says that we can't have 4 sets of the same quantum numbers. So this electron, I screwed that up. This electron has to go in as a minus 1/2. That's why we put it as a down spin. No 2 electrons can go in the same orbital or the same box with either 2 up spins or 2 down spins. They have to be opposite. It's the only way they make this work. So now the third electron. We'll keep doing some examples here. This is now full down here. So the third electron has to go to the next lowest. The common method of doing this, or common convention of doing this, is to always start with an up spin electron. So I put an up spin in the 2s orbital. So we go, okay, it's in the second energy level, s sublevel, and it's a plus 1/2. Now I'm not even going to go back to the page. The next one is going to go in the same box, but it's going to be a minus 1/2. So it's going to be minus 1/2. Now the fifth electron. The next lowest sublevel is the 2p. So it's going to go right here. Now remember, the p sublevels are labeled x, y, and z. So this is a 2px. So it's in the second energy level, but now it's in a p sublevel, and that p orbital is labeled with an x plus 1/2. The sixth electron, you might be tempted to put it as a down spin here, but remember Hund's rule said if you've got orbitals of equal energy, they single them up before you double them up. So unless all of them already have one, I can't double this up. So the next one will go here, and the next one there. So we're going to do 2 at a time here. So we got 2p. It's in the y as a plus 1/2. We've got another one that's in the 2p, but the second one we put in, or the third one there, was in the z box, and it's also a plus 1/2. Now the eighth electron. We have 7 electrons in here. 1, 2, 3, 4, 5, 6, 7. The eighth electron. We've got these all singled up, so the next space for it to go is back into here, but as a down spin. We've got to go back now and put it as a down spin. So the eighth electron goes into a 2p. It's in an x again, but now it's a negative 1/2. So notice that this electron and this electron, they're very similar. Whoops. They're very similar. That's because they're both in the same orbital. It's just that one of them is an up spin, one of them is a down spin. That's how they make it work. I would like you as homework to finish this table. I believe it goes up to like 25 or 30 electrons. Keep adding electrons. So once you fill this up, you'll go to this one, then this one. The next electron will go here, 3s0 plus 1/2. Then here, then we go boom, 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 down, 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 and then it goes up, down. And notice actually, here's the trick. The 4s comes before the 3d sublevel. If you look over here, the 4s and the 3d actually overlap each other. So the 4s does come first. So that's one trick I want you to keep in mind before you take off rolling on that. I am going to save this table for another video, so your job at this point is to complete the rest of this table on your own.